Okay, so we looked at voltage in series and parallel. Now we're going to look up current in series and parallel. So I'll put the voltmeter away and I've got a few different ammeters here. What I want to do is I want to measure the current here. I want to measure the current here and here, and then, or maybe just one of them. I'm going to put an ammeter here and here. Okay, so I'm going to do that now. I'll pause the video. Okay, I'm actually going to video myself doing some of this to show you how to use this. So you click on the wire, press delete, then you get this, and then you just connect it up like that. And I can just close the loop there. So we've got, it reads 0.45 amps. Let's do it beforehand as well. I've broken the circuit, so no current is flowing at the moment. And over there, also 0.45 amps. Okay, I'll pause the video and make the other ones as well. So let's close that one. Oh, delete that bit. And then delete this bit. Okay. Oh, I hadn't actually paused it. Okay. So let's have a look at this in detail. We've got on the series circuit, the current is the same. And remember, that comparing the series to parallel, the battery is the same, and we've got the same number of light bulbs. So 0.45 amps is in series, and in parallel, it actually changes. Beforehand, it's 1.8, and then at this light bulb, it's 0.9. If I got the current, if I had an ammeter and I'd measure it there, then I would also measure it to be 0.9 amps. So what we can see is the current, which, by the way, what is the current? The current is the rate of flow of charge. It's the amount of charge that flows by per second. We can think about it, if we like, the amount of electrons per second. But it's not actually the amount of, because there's a lot more than 0.9 electrons per second. So it's actually the number of coulombs per second. But anyway, so the electrons are flowing down here. Some of them are going over here, some of them are going over here. So of course we are going to have the current's going to split up. So it would be 0. Again, only if the light bulbs are identical. 0.9 here and 0.9 here. If the light bulbs are not identical, you would just simply, the two currents here and here would add up to the current afterwards. If I measure the current after this second junction, it'll be back at 1.8 amps. And this can also be seen because you can see the electrons are going a lot more quickly here, and then they're slowing down here. So remember, the current is the rate of flow of charge. If the electrons are flowing quickly, then clearly the current is great, and if they're flowing less quickly, the current is not as great. So why is then, the next question to understand then, why is it so, is the 0.45 amps lower than both of these numbers? Well, it's lower than the 1.8 because, remember, the electrons only have to go through one light bulb each, and so these ones are going through two, and so it makes sense that it's going to be faster. But what happens then is that actually, if we look at where the electrons are flowing through just one light bulb, then that's going to be twice as high as the 0.45 over there. But then they're going to join back together again, and that's going to be where they're going to double. So they have to have twice as much current here in order to get the 0.9 here, which is going to be twice as much as this one here. This can also be shown with a formula, which I can do in the next video. But in general, we can say for series circuits then that the current is the same everywhere, and in parallel circuits it splits up, where the this current here plus this current is going to be equal to the original current coming from the battery. Okay, so that's current in series and parallel.